Good morning. Myself, Dr. S. Muthusundari, Associate Professor, Department of CSE. Today, we are going to discuss about the memory and I/O interfacing in the microprocessor and microcontroller. So, first of all, we want to know what do you mean by data transfer. So, in that data transfer in the sense the data that will be transferred between sender and the receiver. Either the receiver can be able to receive the information or the sender can receive so many information from the receiver also. So we are having two types of transfer, synchronous and the asynchronous. First of all, we want to know what do you mean by interfacing. The process of interconnection of external devices to the microprocessor, which is called as interfacing. So external devices such as keyboard or display, etc. So what do you mean by interfacing in the sense? The process of interconnection of external devices. For example, suppose in the class, if I would like to do some presentations to you regarding certain topics, then definitely I have to give laptop and then I have to give the password for that internet access, and then I can able to show my PPT to you. So these are all about certain things that we are going to connecting the external devices. That is called as the interfacing. So now a lot of intermediate we have in the MPMC. One is called as the parallel communication interface, serial communication interface, timer or counter, keyboard or display controller, interrupt controller or DMA controller. So here in this, all the interfaces that we are going to discuss one by one. So in this lecture, we are going to discuss about the parallel communication interface, the name which is called as 8255. So now today we are going to discuss about the concept of parallel communication interface, the name which is called as 8255, which is developed by the Intel company. So it is in the name of Intel 8255 interface. So the chip 8255, which is also called as programmable peripheral interface. So which is developed by the Intel family, and then either it may be of 8-bit processor or it may be of 16-bit or it may be of higher capability microprocessor. Totally, it has 40 pin of the integrated circuit. It is very flexible and then economical. So this diagram shows the pin diagram of the 8255. So totally, as I said, it is a 40 pin diagram. So 40 pin in the sense, in the left hand side also we are having 20 pins, and in the right hand side also we are having 20 pins. So 20 plus 20, 40 pins. Okay. So here in that 40 pins, easily you can remember mainly one for the plus power supply and another one for the ground. Okay. So 2 pins are allotted for that. And again, we will having some chip select option. Either read operation is going to perform or write operation is going to perform, or we have to perform the reset operation also. So for that, separate pins are allotted. Read operation, write operation, chip select, and then reset. So 4 pins are allotted for that. So 4 plus 2, 6 pins are already allotted. And then we need data bus as well as the address bus. Whenever we are speaking about the microprocessor, immediately it comes to know it has some data buses and the address buses. Through the data buses and the address bus only, it can able to transfer the data, or it can carry the information from sender to receiver. At the same time, either it can carry the data or it can carry the address. So for that, we are having 8 data buses. So it starts from D0 to D7. And then we are going to allocate some 2 address bus. So A0 and the A1. So 8 plus 2, 10. So totally 10 pins are allotted for the data bus and the address bus, and then 2 for the power supply and the ground symbol, and the remaining 4 for the read operation, write operation, chip select, and the reset. So totally 4 plus 2 plus 10. So 16 is allotted. And then the remaining 24 pins, which is mainly for the port. Okay. So here we are divided into 3 ports: port A, port B, and the port C. So the ports which are called as the output lines, input-output lines. So each will be having of 8 pins. Up 8 into 3, 24. So 24 plus 16, totally 40 pin diagrams. The group which are called as group A, group B, and the group C. So port A, port B, and then port C. Each will be having of 8-bit. So PA0 to PA7, PB0 to PB7, PC0 to PC7. In that 3 ports, mainly which are grouped into 2 groups, group A and the group B. So group A, all the port A plus the upper part of the port C. Whereas in the group B, all the port B, then the lower part of the port C. So it is divided into 2 subdivision. Next, we will discuss about the signals of the 8255. So what and all we have discussed here. So here we have the address bus, data buffer. Okay, so data buffer is there, chip select is there, reset button is there, A0, A1 for the address, read operation, write operation, and then plus power supply, ground, and then these pins are identified as the input and the output lines totally, which are grouped into port A, port B, and then port C. So now it has 24 input output lines, which may be individually programmed. 2 groups of IO pins are named as group A and the group B. As I said, the port A and the upper part of the port C, which is called as the group A, and then the port B and the lower part of the port C, which is called as the group B. So 3 ports, port A, port B, and the port C. Next, data bus buffer. So totally, which is having of 8-bit of lines, D0 to D7, mainly which is used to carry the information. And then chip select. Mainly, if the line is a logical 0, then the microprocessor can read and write to the 8255. And then the reset button is also available. Read operation, which indicates either the read operation is going to be performed, or write operation, it indicates either the write operation is going to be performed. A1 and A0, these are the address lines and are driven by the microprocessor. Then control logic. Based on the chip select and the 2 ports of the address, either the port A will be activated or port B will be activated or port C, or nothing will be chosen. This is the block diagram of the 8255. Here, already we have said there are basically 4 components in it. One is about the data bus buffer, and other one is about the read-write control logic. Then the remaining about the group and the ports concepts. Okay, so already we have specified 8 bits of data bus buffer, and then read-write control logic. Here it indicates read operation, write operation, A0, A1, and the reset, and then chip select. And then here we will be having a group A, which consists of group A, port A 8 bits, and then port C upper bit. Whereas the group B, which is called as port B as well as the port C of lower part. So these are all the block diagram of the 8255. So mainly the block diagram of 8255, which has 40 pins, mainly which consists of 4 parts: data bus buffer, read-write control logic, group A and the group B, and then port A, B, and C.